What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it again because we are coming up to SAT on this Saturday, May 4th. So if you're watching this live, you know that there's an SAT this weekend. There's a good chance you're probably taking the SAT this weekend. And if you're watching in the playback, obviously this is just another great practice test for you to use for your studying and review and all that stuff. And as I've said many times before, in my opinion, when it comes to preparing for this test, it's all about the practice. It's all about getting your reps in, seeing as many different angles of variations of types of practice materials that you can, that are obviously well honed to the real test. And that's going to really get you to where you want to be, to get you to max out your math score. So we're going to do another practice test from the SAT Crash Course, which is the company that I partnered with. I support their practice tests. I think they're excellent. And not only that, I've created video explanations for their 10 practice tests that are available. So if you buy their 10 practice tests, each and every single problem, this isn't anywhere else, by the way, each and every single math question has a custom video explanation. So you can go through each one. Even if you got it right, you can watch, see how I did it, and you can learn from that. So I highly encourage you to check that out if you haven't done so yet. By the way, there's a special promotion running right now for SAT Crash Course. Whatever you buy is going to be 40% off. That's only for the next couple days. So even if you're not taking the May SAT, I highly recommend you take advantage of this deal and purchase and sign up now, and you can use it later in August or whenever. Moreover, you can still use the code SCALAR, so you can get 40% off plus an additional 20% off. Now that doesn't mean 60%, right? You're going to take 40% off and then 20% off that remaining chunk. So anyways, I really recommend you take advantage of this deal. This promotion, as I've heard from the company, will never happen again. Nothing like that. I mean, that's a big promotion. So take advantage of it if you do plan to use the resource. And if you're just here to check out the live stream, well, welcome, and let's get into it. All right, we're going to skip through module 2 for the reading and writing section. We're going to go straight into the mix with math. We're going to do module 1 right now. And then later today, if I can make it work, I'm in my busy season for tutoring. Later today, if I can make it work, we're going to get into module 2. And that's it. And again, I'm going to have content Thursday and Friday. So make sure to subscribe if you haven't done so yet. And give this video a like if you do enjoy it. All right, here we go. We're going to start in 3, 2, 1. Let's go. And we got a little whiteboard whenever we need it. All right, numero uno. Which equation is the same solution as a given equation? Well, the solution is if I add 9 to get 24, right? So 3y equals 24 divided by 3y equals 8. So this would be y equals 5, so that's out. This would be y equals 9, that's out. This would be y equals 8. C is the winner. Let me just double check. Yep, C is the winner. Boom, done. All right, number 2. We got a figure. We got angles. U is parallel to V. What is the value of Z? So these two are parallel. So what is the value of Z? Well, here's the thing. 5Z and 146 are what are called corresponding angles, okay? Because they're in that same position coming down the transversal. And if they're corresponding, that means they are equal, which you might guess because they look equal. So solve for Z, we just divide by 5. And what is that? That is like 29.2. 29.2 for the win. Hold on, let me make sure. Value of Z. Didn't make any mistakes. Yep. Boom, done. Number 3. Each value in the data set shown represents the number of pages. What is the median? Okay, so what is median? Median is the middle of the data set. So I'm going to show you 2 ways to do this. We can, one, arrange. Actually, I'm only going to show you one way. I'm going to describe the other way. One way, if you're going to do it by hand, is you want to arrange these from least to greatest, okay? And find the middle value. But what you can do in the calculator, which is pretty slick, is you can use the median function and you can put in all these values. You just want to make sure you want to triple check that you didn't make any mistakes as you're entering them. So I'm going to do it really carefully, right? 50, we got 40, we've got 45, we've got 24, we've got 55, we've got 31, and we've got 49. And it spits out this nice 37.5. If I have time, I'm going to double check. Let me see if I can do it real quick. So we got smallest, next small. So that's how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to take the average of the 2 middle. So we got littlest. So that's 1, 2, 3, 4, 5 is 35. And the next one up is I think it's 40. So yeah, it makes sense. It's the average of 35 and 40, the fifth and the sixth values, the two middle values. So anyways, that's how you do it. Boom, done. Okay, number 4. The given equation describes the relationship between the number of muffins, number of cookies, bakery. If the bakery bakes 5 cookies on a given day, where's the number of cookies? N is the number of cookies. So this is a plug and chug. We're trying to solve for M. So 7M plus, it says N, which is the number of cookies, is 5, is equal to 73. 7M plus 10 equals 73. Then we're going to subtract 10 from both sides. We've got 7M is equal to 63. Divide both sides by 7M equals 9 for the win. Boom, done. Number 5. A cube has a volume of this. And a cube is basically a 3D square, right? All the side lengths are equal, x, 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 okay? What is the surface area in square meters of the cube? So to find surface area, first I need to know the side length. Well, I know that x times x times x, which is x cubed, is equal to this volume. So to solve for the side length so we can get the surface area, I need to take the cubic root of both sides. Let's do that in Desmos. Oops, not that shortcut, cubic root. So one way that I like to do cubic roots, just to save time, what's that number? 5, wait, let me make sure I have it down. 50,653. 50,653 is I raise it to the 1/3 power. It's the same thing as a cube root, and that's 37. So the side lengths are 37, 37, 37. So a cube, all the faces are equal, right? All of these are the same. So I just need the area of one face, and then a cube has 6 faces, so I multiply by 6. So the area of one face is 37 squared, and then I take that and I multiply it by 6. So 37 squared, let's do it down here. 37 squared times 6 is 8214. 8214 for the win, boom, done. Number 6, here we go. Okay, watch how I'm going to write this. As I'm reading it, 20.4 is P percent, that's P out of 100 if it's a percent, of means multiply 60. And just like that, as I'm reading it, I've turned it into an equation. Again, I've never seen this question before. I'm doing it in real time, but I've become so accustomed to converting it into an equation as I read it that it just makes it so much easier. So I want you to apply the same principle. Now we just have to isolate P, right? So first, I'm going to multiply both sides by 100 to actually, look, let's just simplify this. 60 over 100 is 0.6. So I'm going to do 20.4 then divided by 0.6. Let's use decimals just for fun. 20.4 divided by 0.6. And we get 34. 34 for the win. Does that make sense? Let's see. 6 is P percent. So 34% of 60 should be 20.4. That'll be 18 plus 2. But yeah, it's exactly right. Boom, done. All right, number 7. The model predicts that the number of computers, let me make a model. So the number of computers sold by a company was 10,000 in 2015. The model also predicts that each year for the next 4 years, the number of computers sold S decreases by 5%. This is an exponential equation. So that would be like times 1 minus 0.05. It's decreasing by 0.05. And then it's, for the next 4 years, the number, it's 5% from each year. So I'll put X as every year from 2015. So it's when it's 1, it represents 2016, so on and so forth. Which equation best represents this model? We got it. We already got it. So I have it set up. It's not A, close. It's B. 10,000, because 1 minus 0.05 is 0.95. Always we have the initial value, the value we start with at time 0, which is 2015, according to this one. So 10,000's got to be in the front. So you know it's either B or D, but D is showing growth. That's over 1. So they're not talking about growth, they're talking about decreasing. So B has to be the winner, boom, done. Number 8. What is the negative solution to the given equation? I'm going to show you 2 ways to do this. First, we're going to do it by hand, then by Desmos. Do it by hand. Again, we're going to use the zero product rule. 5x squared minus 21x minus 20 equals 0. And then we're going to have to factor this. We're going to do little star method. 5 times 20 is 100 up top. Negative 21 down here. What 2 numbers multiply to 100 add to negative 21? Wait. 5 and 20. 4 and 20. 4 and 25. 4 and negative 25, right? That plus that is negative 21. And then again, we have to put the A values, which is 5 here, right? That's my A value. This simplifies to 1 over negative 5. So it factors to 5x plus 4. The bottom number is the standalone constant. Same here, 1x minus 5, okay? So it says, what is the negative solution? This gives me positive 5, so not that one. This gives me negative 4, fifths, right? Negative 4 fifths times 5 is negative 4 plus 4 is 0. And we're trying to get it to equal 0. So negative 4 fifths is the answer. Now, if we did it in the calculator, you could do it like this. What I like to do is I make the left side its own equation, 5x squared minus 21x. And then the right side, y equals 20, its own equation. You could also put y equals here, sort of arbitrary. It kind of assumes it's there. And then look for the intersection point. So I see one intersection at positive 5 for x. That's not what we want, but here's the one at negative 0.8. In fraction format, it's right there, negative 4 fifths. Oh, there's a little trick. I wonder if it's activated. I'm going to see if it works. So if you do negative 0.8, you can click this button, just a little tidbit, and it'll give you the fractional equivalent. So again, I don't know if this is activated in the College Board's Desmos, but that's usually available. So just a little super tip, if you will. Negative 4 fifths, boom, done. Number 9. 2 bar graphs represent the number of pets owned by students in Class A and Class B. Which statement best compares the mean of the number of pets owned by the students in these two classes? Okay. Wait. I can't compare. Oh, I can. Okay, hold on. Never mind. I thought it was like this was a range of values. It's not. So we have to get the mean. All right, so let's write here. This is what I'm going to do. Let's write this out a little bit more carefully. Blop. All right. So we've got, just so I can write on this, so we've got 5 people own 1 pet. Yeah, I would have loved to seen some labels here, but I'm assuming this is like, hey, this is owning 1 pet, 2 pets, 3 pets, 4 pets, 5 pets, right? Anyways, and there's 5. This is the frequency. So 5, 8, 6, 2, and 5. And then here we have the same distribution. It looks like 5, 8, 6, 2, 5. Okay. Actually, wait a minute. The values are pretty much identical, except for, the frequencies are identical, but this is shifted up. Obviously, A is going to be a bigger mean. I don't even have to calculate it. I could. And I could calculate it by saying 5 times 1 plus 8 times 2, add all those up, and then divide by the total number of people there are, which are 13, 19, 21, 26. But I already know A has to be bigger because the same frequencies but larger values. So the mean of pets owning Class A is greater. That's it. C is the winner. Boom, done. All right, number 10. The graph of y equals k of x is shown where function k is defined by this. What? How many distinct values of x does k of x equal? Oh, okay. So this is a crazy thing, but we can just look at the graph. How many distinct values where does x have for where the function equals 0? So what are the x-intercepts? How many are there? That's what it's asking. 1, 2, 3. That's it. 3 is the winner. We don't have to worry about all that. Boom, done. But it did look hard, right? Okay. All right, just checking the comments. Looks like we're good to go. All right, the exponential function is defined by this, where b is a positive constant, okay? If h of 2 equals, okay. So this is a plug and chug situation. We know that h of x equals 24b, which is some constant to the x. And we know that when x is 2, okay, let's write this out. When x is 2, we know that the function value, h, is 768. So we can now use this to solve for b. We're going to first start by isolating. We're going to divide both sides by 24. I'm going to use my calculator to do that. Hold on. 768 divided by 24. 768 divided by 24 is 32. So we got 32 is equal to b squared. So b is the square root of what? Oh, yeah. So b is the square root of 32. It wasn't asking for b, so that's fine. Square root. And well, you can simplify that to 4 rad 2. Not that you know what? That doesn't even matter. Let's just leave it a square root of 32. Saves us time. Now, we can plug this in back to my original equation. So I now know that h of x equals 24 square root of 32 is b, and then to the x power. But now we're trying to find when x equals 4, right? So I'm going to plug in 4 here. And we're going to evaluate it. 24 times square root of 32, hold on, to the 4th power. And there's our answer. Wow, that's big. What? Hold on. So let me just think if that makes sense. And then 24. Let me make sure we got this right. It's so big. It is fine because you can fit 5 digits in there, but I'm not a fan of, I always get nervous when we have really big numbers like this. So if I square it again, I get the 768. Yeah, I mean, it's got to be 24576. 24576. Boom, done. Okay, next. Which ordered pair is the solution to the given system of equations? I'm going to show you how to do this algebraically and then on Desmos. So we're going to substitute. We're going to set these equal to each other, right? Y equals that, Y equals that. So I'm going to substitute that in for that Y up top. So I got negative 4x plus 24 is equal to, and then I'm going to FOIL this out in the same step, x squared, right, times negative 6x plus positive 1x, which is negative 5x. And then 1 times negative 6 is negative 6. Now we're going to bring everything to the right side using the zero product rule. X squared, negative 5x, and we're going to add 4x, so that's negative x, right? Negative 5 plus 4 is negative 1. And then negative 6 minus 24, we got a minus 24 from both sides equals negative 30. Factor, and we get x minus 6, x plus 5. What two numbers multiply to negative 30 add to negative 1? And that gives me my two solutions, which is x equals 6 and negative 5. And then to get the corresponding y values for each of these, we can go like this, and plug and chug into either equation. Let's plug into the bottom because it's easier. Actually, top. Because plugging in 6, we get the 0, so that's one solution. And then the bottom one I'm going to use for negative 5. Negative 5 times negative 4 is 20 plus 24 is 44. So those are our two solutions. I only see 6, 0. Boom, done. Now I'm going to show you how to do this in Desmos. And you might have a preference for this, and I do recommend it if you like this method. Y equals x plus 1, x minus 6, y equals negative 4x plus 24. And it's a system of equations. We're just looking for the solutions, aka the intersections. There's my 6, 0. Boom, done. There's the other one that I mentioned, negative 5, 44. All right. Moving on to numero 13. Triangle ABC is similar to DEF. Let me get two triangles like this. Boom. And we got this. And it says A, B, C, D, E, F. It says, you know, A corresponds to D. We kind of know that already, though. When it says ABC is similar to DEF, it's in that order, but it's just kind of saying for our benefit. B and E are right angles. Ooh, I wish I would have drawn this as right triangles, but it's all right. These are the right angles. And then it says if cosine of A is 20 over 29. I hate when it's not. You know what? I'm going to have to redraw this because I hate looking at it like that when they're not right triangles, what they're supposed to be. So let me do it again. I'll do it quick. So doot, 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 and then doot, doot, doot. Right angle, right angle. So B and E are right angles. The other two are just kind of arbitrary. I'll say A and C, D and F. Again, just in that same order. So then it says if cosine of A, cosine is adjacent over hypotenuse, is 20 over 29. So the adjacent could be 20. The hypotenuse could be 29. What is the value of sine of D? Now, again, because they're similar, sine of D is the same as sine of A. So I don't even care about this triangle. All I need to know is that I need to find sine of A. But I don't know the opposite side. So we got to figure that out. We can use Pythagorean's theorem. 20 squared plus, I'll call this x squared, equals 29 squared. Let's use calculator. So 29 squared is 841, and then we're going to end up minusing 20 squared, which is 400. And that's 441 is what x squared is. We got to take the square root of 441, which is 21. So this side over here is 21. So sine of A is opposite over hypotenuse, which is 21 over 29 for the win. Boom, done. Okay. Numero 14. The function P of T models the number of plants, garden hours after initial. How many hours does it take for the number of plants in the garden to triple? Okay. This one you can do pretty instantaneously, and I'm going to show you why. It's tripling is the factor in the exponent, right? So every time this exponent goes to multiples of like 1, 2, 3, it's going to triple. Then it's going to triple again. So the first time it's going to triple is when this exponent goes to 1, and that's going to happen when t is 650, because 650 over 650 is 1. So I already know the answer is 650, but if that didn't make sense, what you can do is this. You can be like, all right, let's see where we're at here. I'm going to put in this function, 3 to the, x. You have to say x when you do it in Desmos, not t. Otherwise, it won't work. And then be like, all right, I got this graph. Cool. Where is it at time 0? It's at 1200. All right, so when is it going to hit 3,600? That's triple 1,200. So let's see where 3,600 is. Oh, right there. Look at my X value, 650. You see what I'm saying? So you want to be creative. If you get stumped, just think about how can I use the calculator to make some headway here, because there's a lot of options. Give an equation, blah, blah, which correct. Okay, this is a straight up isolating quantities question. We're isolating 2C. I'm not going to read anything else, and let's begin. So I see that's on the denominator. I'm going to do my first step as I write it out. I'm going to multiply both sides by that denominator, especially when what I'm trying to isolate is in that denominator. So we're going to multiply both sides by 2C minus 3. That's going to kill the denominator on the right-hand side, and we just got B minus 7. Then we're going to distribute, because I, again, want to isolate that C. I got 2AC minus 3A equals B minus 7. Now I'm going to add 3A to the other side, trying to isolate that C. 2AC equals B minus 7 plus 3A. Again, no like terms, so everything stays separate. Last but not least, we need to get rid of the 2A. So let's get, oh no, we're trying to isolate 2C, excuse me, and we need to just get rid of the A. So divide both sides by A, divide both sides by A, blop, and here's my answer. Okay, so they don't have it exactly, but I'll show you what they did. So 2C equals B, I'm going to do it like this. So we can put every individual term over A separately. B over A minus 7 over A plus 3A over A. Well, these two, the A's cancel out, and that's why I'm left with a 3. But these two we can remerge, because why not, right? They have a common denominator, and there's nothing else we can simplify. B minus 7 over A plus 3. That gives me D for the win. Boom, done. 16. Let A... Line A is defined as this. Line B is parallel to A. B, okay. So we got parallel lines, and then we're trying to find the x-intercept. So I'm going to show you by hand, and then I'm going to show you via Desmos as well. So the first thing is, if this is a line, and they're saying they're parallel, and I know that parallel means they have the same slope, I need to know what the slope of this is. So to do that, I'm going to isolate y. So I'm going to say 7y equals negative 2x, right? Minus 2x from both sides, plus 14, and then I'm going to divide by 7. Y equals negative 2/7 x. 14 divided by 7 is 2. Now I know my slope is negative 2/7, right? So my slope is negative 2/7, and this is going to also, line B is going to have a slope of negative 2/7, but I only have a coordinate. Let's use point slope. So y minus negative 5, which is plus 5, equals my slope negative 2/7 times x minus that x value, x minus 7, okay? And now what we're going to do is we're going to go distribute, y plus 5 equals negative 2/7 x. And then negative 2/7 times negative 7 is positive 2. And then we're going to minus 5 from both sides. Y equals negative 2/7. 2 minus 5 is negative 3. And my y-intercept is then this value, right? Whatever that value is out there, negative 3. Okay, let's think about how to do this in Desmos here. Calculator. Actually, wait, yeah, this would have been pretty straightforward in Desmos. So 2x plus 7y equals 14. Okay, let's hit that home button. Now, you might not see what the slope is here, and you might want to still isolate, but you can kind of be like, oh, wait a minute, it's going down 2 over 7. That's negative 2/7. So you know your other equation in point slope is y minus negative 5 or plus 5 equals negative 2 over 7 times x minus 7. And it's now asking for the y-intercept. I can see it, negative 3. Actually, that was pretty cool. Desmos was definitely faster. All right, here we go. In a circle with center x, let's draw it out. We got a circle with center x. Points y and z around the circle. Okay, the length of arc yz. That is 1/10 of the circumference, okay? If that's 1/10, by the way, remember that the fraction that it is of the entire circumference is equivalent to the fraction of 360 going all the way around. So I'm just going to put it out there. I know my central angle is 36 degrees. I'm putting this out without even reading the rest of the question, but I like to put in that information if I can. And then look at that. It's asking that y, x, z. And I'm telling you, I have not seen this practice test, right? So a lot of the instincts that I have, fine. Maybe it's from just like years of practice and repetition. But I do think that took like 2 seconds. And if I didn't need that information, it's not the end of the world. But I'm thinking like that, right? So anyways, we got our answer. 36 is the winner. Boom, done. 18, which of the following could be the equation of the graph shown? All right, so what I'm seeing here, and I'm just going to tell you before I even look at the options, I'm seeing a x-intercept at -3, which means it would be x plus 3. But since it bounces, we're going to assume it's an even multiplicity, probably going to be a multiplicity of 2. So I know I should have x plus 3 squared. And then I have another x-intercept at +4, so I'd need x minus 4. And those are the only two x-intercepts. And then we'd have some constant in front of here. And now, since it goes up to the left and down to the right, it's going to be something negative, so some negative a value. If you don't know that it's got to be negative, again, you can try these values out in Desmos and double check. Okay, now let's see what we got. This is wrong because of the x. That would mean that there would be an x-intercept at 0 as well, so this is out. The wrong value is squared, that's out. This one, the right value is squared, that's squared, and that's negative, so it's got to be this one. This should have another x-intercept at -5. Obviously, it doesn't. So C is the winner. But again, you can go through and graph these guys and compare to the in Desmos and compare them to the graph above. Boom, done. 19. For z is greater than 0, the function k is defined as follows: k of z equals 17. Okay, watch this. K of z equals 17% of z. All right. So here's the dealio, right? This is just a straight up constant value. So what I'm going to say is this is a linear function, but it's actually a positive slope. Even though it's a fraction, it's still going up like this, okay? So I'm going to call, as like just reading it straight up, 17% of z, I'm going to call it that. But a lot of times, these percentage questions, you're taking like 17% each time of the previous value or whatever. That's going to be describing an exponential. And if each time you're getting 17% of the previous value, that would be decreasing exponential. But anyways, the way I'm reading it, interpreting it, I'm just translating it right over. This is the winner, increasing linear, boom, done. Number 20. The function r is defined by this equals this. Okay, so r is literally this equation plus 4, which would be -x squared plus 10x, and then -247 plus 4 is -243. Okay, for what value of x does this reach its maximum? Again, I'm going to use Desmos. All right. Now, oh, by the way, I could also use, actually, no, faster to not use Desmos. The minimum is going to be at the vertex, which where this is A and this is B, is at -b, which is -10 over 2a, which is -1. So -10 over -2 is +5. So I know it's C. But if you want to see it in Desmos, right, you graph what I just wrote, -x squared plus 10x minus 243. There's my thing. Where's the vertex? There it is. And it's at 5. The thing that I bet a lot of people would do is they'd accidentally write this in. They'd miss that little detail, so make sure to pay attention. We're at question 20. Even though it's module 1, this is where it gets a little tricky, so be mindful. 21, we got 2 left. Here we go. The table shows the results of survey of people favorite pizza toppings. Total of 237 people were surveyed. 199, yep. If 1,014 people ordered a pizza, how many more people would choose cheese than other toppings? So cheese minus the other 2. So in this case, it'd be 136 minus 63 plus 38 is 93, 101. So it is 136 minus 101, which is 35, okay? So it's 35, but what do I do with this number? It's that much more, right? So that would be 35 out of my total of 237. That's the fraction of people that represents the more. But now I need to apply it to that total of 1,014. So now I need to multiply this fraction by 1,014. Let's do that now in Desmos. 35 over 237 times 1,014. And we get about 150. What? Why is it a decimal? Well, I do see 150. How many more people would be expected to choose? Yeah, so maybe 150. That's my closest answer. Wait, let me make sure I didn't make a mistake real quick. So then 237 people were surveyed. If 1,004, okay. So then here, let's actually do the numbers. So then cheese would be 136 over 237 times 1,014. This is probably going to give a fraction too. 136. I know this is going to be the same value, but all right, it's 581. And then the other 2 would be, what did I say it was? 101, yeah. And then the other ones would be 101 over 237 times 1,014. was 237, right? Did I not? Yeah, I got that right. So that's the difference of these two. 581 minus 430. You can see it's about 150. So we're good. B is the winner. Boom, done. All right, 22. In the given system of equations, m is a negative constant. The graphs of the equations intersect at exactly 1 point, okay? Now, I'm going to stop right there. When we have a line and we have a parabola intersecting at exactly 1 point, it's going to be some sort of a tangent, right? It's going to be like just barely touching like that, all right? M is a negative constant. Oh, that means the slope is negative. Let's do a better, more accurate drawing. So like this. Boom. Okay, so there's my representation. And in the xy plane, what is the value of x? So we want, okay. So we want to solve for x at the intersection point. All right, so let's check this out. So first, I'm going to set these equal to each other and do a little substitution. So we've got mx minus 2, which equals y. So I'm going to plug it into that y, equals 3x squared minus 4x plus 1. And then I'm going to set everything equal to 0. So I got, excuse me, 3x squared minus 4x minus mx. I can't combine those because of the m. And then add 2 to that side, that's plus 3. All right, so this equals 0. Now that we've got this, what am I going to do? When they said intersects exactly 1 point, that means one solution to a quadratic. What should that remind you of? The discriminant. So in this case, we want for one solution, we want the discriminant to equal 0. The discriminant is b squared minus 4ac. So, and what is my b coefficient? Well, I got to factor out the x. It's x times negative 4 minus m, right? 3x squared and then plus 3. So my coefficient, so my b value is negative 4 minus m squared, b squared, minus 4 times a times c, and this has to equal 0. Now I can start to figure out what m is, all right? So 4 times 3 is 12 times 3 is 36, and then that's negative 36. I'm going to add to the other side is 36. Wow, I'm running low on time for module 1. That's crazy. And then I'm going to FOIL this out. So negative 4 minus m squared, it'd be negative, again, you have to FOIL it. So negative 4 times negative 4 is 16. Then negative 4 times negative m is 4m, but then you're going to do it again. So it's 8m and then plus m squared. Another quadratic. Okay, then we got m squared plus 8m, but a minus 36 from 16, which is minus 20 equals 0. And then we're going to get, it looks like 2 values for m. So we got m, boop, boop, m. So what two numbers multiply to 20, add to 8? That's positive 10, negative 2. But it did say m is negative, so this would give me positive 2. So m is negative 10. All right, let's just plug it into Desmos now, and we'll find the intersection. So then we got y equals negative 10x minus 2. And this one is 3x squared. What is that? Minus 4x plus 1. Minus 4x plus 1. All right. So we need to zoom in a lot. Let's find that intersection point. And does it indeed intersect at exactly 1 point? It does. Look at that. And my intersection point for x is at negative 1. Okay, I feel pretty confident about this module 1. So what we're going to do is I'm going to submit this. And we are going to pick up, I think later today, I'm going to find a window where I'm going to come back and do module 2. So make sure to join us for module 2. And then I'm going to go through the entire test and make sure, I answer all your questions and all that. Improve pacing, your question to that, straight up practice, practice, practice. The more you practice, the faster you're going to get, the more accurate you're going to get, the more likely you're going to see those little traps and mistakes that are silly mistakes, right? So that's it. That's the key. That's why SAT Crash Course is awesome, because they have so many practice tests. And then there's other resources out there after that if you want to try those as well. All right, guys, I am going to jump off, but thank you guys so much for joining. Like I said, I will be back later today, whether it's in the afternoon or late at night when I'm done teaching. It's going to happen. So thank you guys so much for joining, and I'll see you in the next video. Take it easy. Very welcome.